Hello, this is lab one, understand a product. So today I want to talk about what is the composition of the product and the features as well as the product life cycle. And first, I would like to introduce a concept. It's called a bill of materials. So some of you probably have already heard about this term. So this bill of materials, or BOM, is a list of raw materials, sub-assemblies, parts, and all the other all other quantities needed to make a product. And so the BOM can include several different type of information. For example, the component or the part name and part number, the model number, the quantity, the price, the figure, as well as description and some other information related to it. And so it does contain a lot of data in it. And there are different types of BOMs. One type is the engineering BOM. So basically it's used for design, and typically it's based on computer-aided design. For example, you draw some parts, it has part dimensions, it has part numbers, part name, and quantity. So it can all be extracted from there. While sometimes you probably have to manually input or enter all this information in a system. So the BOM document really lists the parts, components, as well as sub-assemblies that are used in the design by the engineering team. So this is the more technical aspect of the part information, part data. Well, there can be another type of the BOM, which is a sales BOM. For the sales BOM, it focuses more on the quantity as well as the price of the items, and also some other related specifications of the product. And the main purpose is this BOM is used for the salesperson to for purchase and also marketing. And another type of the BOM is a manufacturing BOM. So manufacturing BOM typically is used for the manufacturing itself. And it may contain several different information. For example, the quantity, the assemblies, and the level of the parts. So you know which components actually is a subcomponent of another system. So this information should be pretty clear, illustrated in the BOM. And you can see from this example that it includes all the relevant information in the BOM. Sometimes you can also add a note related to how to assemble it in the workstation. So idea is this BOM is used for the manufacturing engineers to organize the production data. For example, the inventory. Another type of the BOM is a service BOM. So service BOM it includes a list of all the parts, installation steps, and also repair instructions, because these information are more focusing on the service technicians when you're installing and serving the product, for the customers. And next, for a product, usually it has different levels of the parts. For example, in this case, the whole product is first level, in the part tree, and then in the product tree, and then you'll see these kind of subcomponents like handlebar, seat, wheel assembly, and frame assembly. And furthermore, you can actually decompose, disassemble wheel assembly into some other parts. And so this is how you show product actually have different levels of the parts, and also give you a better idea of how this product is actually constructed. That kind of leads us to a concept that's called product tree. And how do we draw a product tree? Typically, a product tree is actually a visual tool used to prioritize the product feature requests and manage input from stakeholders and customers. And a product tree typically started with a product name, so which is at the very top level. And then you look at what are the level 1 components, right? So which means that is some major parts of the or major modules of the product. See here, there's the parentheses. In the parentheses is the number, and it shows that for each X, right? For each X, how many A's and how many B's, right? And same with this part. Well, C, parentheses 2 and D parentheses 1, which means that for each A, there are 2 C's and 1 D. Well, what about if I change this number, A parentheses from 1 to 3? The numbers for C and D is still the same because this is for each. This is for each A, right? All right. And another thing I would like to pay attention to is for different levels. Usually, the top level is level 0, and then you can go, with this sequence of 1, 2, 3, 4, 5. And there's a term, it's called low-level coding. So low-level coding means for the same part, for example, A, all A's should be at the same level, right? If A is in a level 1, then all A's should be at the level 1. Same thing with B, C, and D. Well, how do we find out which level? For example, if D are in multiple levels, how do we find out which level it should be? Usually we go with the lowest level of the of that part. For example, if D it was in both level 3 and level 4, then for a low level coded tree, then we're going to put level 3 of these to a level 4. That means all these should be in a level 4. So that's called low level coded product tree. Next, I want to talk a little bit about the features of a product. So the product includes the physical features, functional features, as well as added value. And first, let's start with the physical features. So physical features means what this product is actually physically, physical properties of it. Physical property can include materials, composition, dimension, color, design, surface, and also some other mechanical property like the force, how much stress it can tolerate, something like that. Materials is the one component of the physical features. When we are analyzing or designing a product, one of the things we need to figure out is what material we want to use. Do we want to use metal materials, ceramics, polymers, or composite materials? It really depends on the purpose of this product and what in the environment it will be used, right? And in this course later, we're going to talk a little bit more about materials and their physical and mechanical properties. And the next one is the composition. So for a product, we're going to look at, okay, what kind of parts is composed, and also how these parts actually work together. So the composition. And dimension is another aspect. When we're designing a product, we want to look at what dimension is more feasible, is more ideal, and why, right? So usually you need to draw this, the parts in a CAD file, and then come up with an engineering drawing to show it. And color is another aspect in the product. To figure out what kind of color may be more appealing. And also ergonomic, because some of the colors contrast need to be clear enough so others can actually easily read, not so disturbing to the users. Design, some designs can really make it more convenient for the users. very easy for user friendly. Some of the designs can be maybe a little bit confusing, right? So for example, this door, some of the doors can be designed, can easily tell it is push or pull, but if it is poorly designed, it can make it confusing. See, this is a big improvement of the remote controller, and a simple design versus a really complicated version of the design. And for the surface texture, it really includes several aspects. So one is the roughness. So when we are talking about roughness, basically it is this very tiny waves here, right? In the on the surface. And also we have this waveness. So waveness, we're looking at more of a larger scale of those waves, right, up and downs. And also we can see the lay. So lay, basically that's the direction of these lines, right? This is called lay. Of course, another aspect is called flaws, right? It's flaws. Flaws are defects of those. And there are multiple manufacturing methods can actually help improve the surface texture. For example, try to reduce the surface roughness and make it more smooth, and also to fix or repair some of the flaws. And other physical features can be thermal properties, electrical properties, electrochemical, or volumetric and melting properties. It all related to the functional or working environment of the product. And another type of feature is the functions feature. So functions feature basically look at what kind of functions it can achieve. For example, the phones, what kind of functions they have, and also cars. In the past, cars is only for driving. Now, you can add a lot of entertainment in the cars right now. And also another aspect of the product feature is added value. So added value means more about the service part of the product. All right, so that's pretty much for the explanation of understanding the product. For this lab, we have an exercise, so which is to build a BOM for a product, and the BOM should include the component name, component number, the description, quantity, cost, and figure, and also you need to draw a product tree. Product tree should include the level numbers, number of parts, as well as part numbers. All right, that's all for this lab. Thank you.